Okay lads, so now we're on to question 5, and once again we're using in each case prove by the results from mathematical induction for all positive integer values of n. So we're proving for n element n, so all natural numbers. Okay, so once again we're going to go through what we've done the last couple of times. This is t1, that's t2, that's t3, that's t4, that's tn. This here means Sn, this here also means Sn. Now essentially you're proving that the left hand side, which is in yellow or green, is the same as the yellow side, which is the right hand side. Okay, so you say RHS equals n over 4n plus 4, and LHS. And you've marked that in the question anyway, alright? So, left hand side, right hand side. Okay, step 1. Test n equals 1. Now n equals 1 means t1, and t1 is 1 over 20. So that's for your left hand side. Left hand side is t1, which is 1 over 20. Right hand side is s1, which is going to be 1 over 4 times 1 plus 4, which is 1 over 20 equals 1 over 20. So this is true for n equals 1. Happy days, right? Now I'm just going to rub that step out. I'm just going to go straight for step 2. Okay, assume true for n equals k. Alright, so this time it's going to be 1 over 4 times 5 plus 1 over 5 times 6 plus 1 over 6 times 7 plus dot dot dot. Now we're going to use, it's not tn, we're going to use tk. So it's going to be 1 over k plus 3 by k plus 4. And that equals sk, which is k over 4 into k plus 4. Alrighty. Now, we assume true for n equals k, alright, and we already know that n equals 1 is true. Now what we're going to do is test n equals k plus 1. Okay, and here's what's going to happen here. So once again, we're working off the premise that, for example, S3 is T1 plus T2 plus T3, and S4 is T1 plus T2 plus T3 plus T4, and we're working off the premise that we can sub out the first 3 values with S3, and that will follow that S of k plus 1 is equal to sk plus tk plus 1. Same thing as S4 being equal to S3 plus T4. It's the same basis is what we're using, alright? So here's what we're going to do. We're going to say it's a 1 over 4 times 5 plus 1 over 5 times 6 plus 1 over 6 times 7 plus dot dot dot. This one here is tk, which is 1 over k plus 3, k plus 4. Now we got to do tk plus 1, which means anywhere you see k, replace it with k plus 1. So it's going to be 1 over k plus 4 by k plus 5. And instead of sk, which is here, we're going to use s of k plus 1, which is going to be k plus 1, replace all k's with k plus 1. And then this k gets replaced with k plus 1, which will make it k plus 5. Alright, And you do what we said we do all along, is you use part 2 to answer part 3. You underline all of this in red. All of that is S of k. And we know that S of k is this part here. So it's going to be k into 4 over k plus 4. And then plus your tk plus 1 over k plus 5 is equal to k plus 1 over 4 times k plus 5. Now, how do we turn the left side into the right side is what we're trying to figure out here. Okay, so let's try and figure out a common denominator system here. So they both have k plus 4s. Neither one of them has a k plus 5. So I'll put k plus 5 here, and probably a k plus 5 up here as well, but it looks of it. I'm going to have to put a 4 here and a 4 here. And here's hoping we can make something out of this. So on top I'm going to have k squared plus 5k plus 4. And on the bottom I'm going to have 4 times k plus 4 times k plus 5. And I'm hoping that that will equal k plus 1 over 4 into k plus 5. Now here's what we're going to do next. I'm going to factorize the k squared plus 5k plus 4. I'm feeling a bit lazy right now, so I'm going to just factorize up here. It was actually k plus 1 by k plus 4. And the k plus 4's cancel. And lo and behold, we have proven that both sides equal each other. Now it's time for the big long spiel at the end of the question. I might even try it this way. True for n equals k plus 1 if n equals k is true. Since n equals 1 is true, this means k equals 1 is true, and therefore n equals 2, n equals 3, etc. Hence, by the principle of mathematical induction, it's true for all n, for all natural numbers. Something to that effect at the end. Okay, we're going to try probably question 7 or 8. I think we'll go for question 7. Now, question 7 just has a small modification at the start, okay? So, with question 7, we're saying the left hand side, right hand side, but the left hand, it's the same question as we just started off. Put in n equals 1. 1 times 3. 1 times 3. Now do n equals 2. And n equals 2 will be 2 times 4. So t1 is 1 times 3. t2 is 2 times 4. t3 will be, replace 3 in here. See, this formula here gives you the tn formula, right? And you can find any term you want just by subbing in for n. So that'd be 3 times 5. And basically plus tn equals plus n into n plus 2. Now what does that equal? Well, the right hand side is the Sn formula. This here is the Sn formula. Okay? And this is n times n plus 1, 2n plus 7 all over 6. And that's your Sn formula. Okay? So we've rewritten the question in parameters we can understand. And off we go. Test n equals 1. LHS is T1, which is 3, equals RHS, which is S1, which will equal, what's it, 1 times 2 plus 9 all over 6. Now you probably want to show the sub in there, to be honest, guys. You probably want to show that you subbed it in, show your intent marks, but just throw it straight into the calculator. 3 equals 3, and then say true for n equals 1. Alright, once again I'm going to get rid of step 1 just because I want to be closer to the top of the board, and now we're going to step 2. Step 2, assume true for n equals k. So rewrite the equation in terms of k. You're going to look for tk, not tn this time. So it's 1 times 3 plus 2 times 4 plus 3 times 5 plus dot 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 plus k into k plus 2. And then we're not having Sn, we're having Sk. K into k plus 1, 2k plus 7 all over 6. Is that okay with you guys? Now 3. Test or prove for n equals test n equals k plus 1. Alright, so remember that's tk, and what we're going to be looking for is tk plus 1. This is sk, and we're going to change that to sk plus 1. So it's going to be 1 times 3, 2 times 4, 3 times 5, plus dot dot dot. Here comes the tk value, k into k plus 2. And then we're going to have tk plus 1, which means replace all k's with k plus 1s. Please remember your brackets, lads. And that k is going to be k plus 3. Equals, replace all k's with k plus 1, so it's going to be k plus 1 by k plus 2. Now 2 times k plus 1, because that's k plus 1 times 2, is going to be 2k plus 2. Then plus your 7 is 2k plus 9. That's all going to be divided by 6. Okay. Now, do what we said last time. Underline all this here. Underline all this here. That there is S of k. This part here is t of k plus 1. And that all equals S of k plus 1. That's for being familiar with sequences and series. It's a bit easier to understand. So we're going to put in our sk value here, which is this box here. So it's going to be k times k plus 1 to 2k plus 7 all over 6. And this equals, oh, forgot something, plus k plus 1 times k plus 3. Alright, and this all has to equal, drag all this across if I can. This all has to equal k plus 1, k plus 2, 2k plus 9 all over 6. Now, how are we going to make this work? Well, here's my logic, right? We're going to use, it's all over 6s, so I'm going to put a 6 here and a 6 here. I'm going to take out what they have in common. Pairs them against the clock. Now give me a second. Now, here's what I'm thinking. I'm thinking what they have in common is they all have a k plus 1 and they all have a 6 on both sides. So I'm going to factorize out k plus 1 and 6 on both of them. So do you see the k plus 1 and the 6? That's going to be factorized out of both of those, okay? So it's going to be k plus 1 over 6, and then in brackets we're left with k times 2k plus 7, which is going to be 2k squared plus 7k. And on this side I only have the 6 by the k plus 3 left over, so that's going to be 6k plus 18, I believe. Alright, and then I'm going to factorize this into k plus 1 over 6, and it's going to be 2k squared, so not factorizing it yet, but alright. And what we're going to do, Control D, it equals that, Control D, I want it to equal that. Has to equal the right hand side eventually. Okay, now that's an 18 by the way. Now guess what happens when I factorize that? It's going to be 2k plus 9 k plus 2. When you multiply that out you get that, and now all of a sudden both sides are exactly the same. Okay, and now we're going to go through the spiel again at the end. True for n equals k plus 1 if n equals k is true, since n equals 1 is true. So basically k takes on the value of 1. This means n equals 2 is true. This means n equals 2, 3, 4 is true, and hence by the principle of mathematical induction, is true for n for all natural numbers. Done. And don't forget your dot 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 there. Okay, happy days lads. Alright, and that's question 7, so I think I did 5 and 7 there.